Lesson 5.1, Solving Inequalities by Addition and Subtraction. Essential question. What information do you need to gather from a word problem in order to write an inequality? So this lesson is all about word problems with inequality symbols. In order to be able to write a word problem, we need to make sure we know which words go with which inequality symbols. So let's start with some of the easy ones. Less than goes with our inequality symbol that kind of looks like an L. Greater than goes next. We have greater than or equal to, and less than or equal to. Then the next couple are the ones that get a little bit more challenging. So let's start with at most. If you think about it, if I have at most 5 friends, then I have less than or equal to 5 friends. At the most I have is 5, but I could have less than that. So at most goes under less than or equal to. Then if I go to at least, so if I say I have at least 5 friends, that means I have 5 or more friends. So that one is greater than or equal to. If I have no less than 5 friends, that means I have 5 or more friends, so that would go here as well. If I have no more than 5 friends, that means I have 5 or fewer friends, so that would be less than or equal to. More than, if I have more than 5 friends, that'd be 5 and greater. If I have fewer than 5 friends, I have 5 or fewer. This is a very important chart that you're going to want to have written in your notes that's going to help you with all the word problems in this lesson and on your homework. Alright, you'll see a lot of writing on this page. First of all, on the left-hand side, it says write an inequality and solve. The sum of a number and 6 is less than -3. We're going to use something called SUI, and I get that because it's S-O-U-I-E, and that's going to help us write and solve inequalities. So here are some of the easy parts of SUI. One of the easy parts is the inequality. So let's look at this problem and find our inequality. The sum of a number and 6 is less than. So I'm going to put a less than symbol next to my inequality. My end width is normally the last number in my problem. So in this case, that is -3. My unknown is always a variable. That's what I'm solving for. So I'll always put x there. Then I've just got my start with and operation left. My start with is always also going to be a number, so the other number I'm given is 6. And then my operation, if you look in this problem, where do you see an operation? The word sum, which is adding. Now I've got a nice inequality written out for me. 6 plus x is less than -3. So if I want to solve that, 6 plus x is less than -3. Draw my train tracks, subtract 6 on both sides, and I'm left with x is less than -9. We are going to use SUI every single time we write an inequality problem. Alright, twice a number decreased by 1 is at least 17. So I can start with some of the easy ones. My unknown, if you remember from the last problem, I said is always going to be x. My inequality is going to be found with the at least, which at least is greater than or equal to. I'm going to end with this last number, which is 17. And then I'm left with my start with an operation. So this time they don't actually give me another number, but they do say twice. Twice means 2. And then twice a number, I have to think about what that means. Twice a number means you're doubling something, which if you're doubling something, that's multiplication. So 2 times x, or 2x, is greater than or equal to 17. So if I want to solve that, draw my train tracks. This is 2 times x. The opposite of timesing is dividing. Oops, that should be a 17. So then I have x is greater than or equal to 8.5. And that is my answer. Now we've got a real scenario. Sam has $65 to spend at the mall. He bought a t-shirt for $18 and a belt for $14. If Sam wants a pair of jeans, how much can he spend? Now, one thing I want to tell you is that SUI works great with some problems, and it's a little more challenging with others. The first two it worked real easily with. This is an example where it's going to be a little bit more challenging for us to figure out. So let's again start with our unknown. Our unknown is a variable, so x. Inequality. There isn't anything about an inequality in this problem, so we're going to leave that blank. Our end with amount is always our total. So what's the total amount that Sam can spend at the mall? That's $65. So I'm going to put a 65 there. Our operation. If we're at the mall and we're buying clothes, so I'm buying a shirt, and I'm buying a belt, and I want to buy a pair of jeans. If you think about the cash register, what operation is the cash register doing as you scan each of those items? It's adding them all up. So our operation is going to be adding. Now I've got to think about what numbers am I starting with? Well, Sam decided to buy a t-shirt for $18, and he started to buy a belt for $14. So we're actually going to have two starting with numbers, the 18 and the 14. All right, let's add our inequality in at the very end. Let's see if we can start setting up this problem. So the $18 t-shirt plus the $14 belt plus the price of the jeans, and then we have $65 to spend. So let's think about this logically. If I want to buy 3 items and I have $65 to spend, I can't spend more than $65. So the amount I spend has to be smaller than $65. Then you've got to ask yourself, could it be exactly $65? Yes, it could. If I have $65 to spend, I can spend exactly $65 and I'll be okay. So here's our inequality. So then I'm going to add that inequality symbol in here. Now if I want to solve this, you'll notice I have some same side like terms. So I'm going to add those together first. 18 and 14 make 32. Now I just have to subtract 32 on both sides. And I've got x is less than or equal to 33. This means that Sam can spend $33 or less on the jeans. Jose plans to spend no more than $50 on 2 shirts and a hat. If the shirts are $10 each, how much can he spend on the hat? Okay, this one is very similar to the last one. Let's fill in our variable, x. Inequality. This time they give us an inequality, no more than. Meaning that's the most he can spend. No more than is less than or equal to. The total amount that he can spend is $50. So I'll put that here. All right, start with an operation. Again, Jose is shopping. He's planning on buying things. So if my cash register is totaling that, they are adding. So now let's figure out our start with number. Here is our key. 2 shirts is what he's buying. The shirts are $10 each. So he's paying $10 for the first shirt and $10 for the second shirt. The hat is our x. That's what we're trying to figure out the price of. So this we're going to set up just like the last one. 10 plus 10 plus the price of the hat has to be less than or equal to $50. I have some same side like terms, so I can combine those. 20 plus x is less than or equal to 50. Subtract 20 on both sides. And I've got x is less than or equal to 30. So that means Jose can spend $30 or less on the hat. Your summary and your homework for this lesson is page 286, numbers 9 through 11, 30 through 36. You do need to use SUI. You don't have to write out what each word means, but you need to have SUI written next to each problem, and then your inequality written and solved.